Have you ever wondered why ice, water, and steam, although all being H2O, behave so differently? Welcome to the fascinating world of matter, where everything that occupies space and has mass comes to life. Matter, in its essence, exists in three primary states: solid, liquid, and gas, each with unique characteristics that set them apart. Let's start with solids. Picture an ice cube. Solids, like our frosty friend, maintain a fixed volume and shape. This is due to the closely packed particles in a fixed arrangement. The particles don't move around but vibrate in place, like a crowd at a concert swaying to the beat. Now imagine that ice cube melting into a puddle of water. This is the liquid state. Liquids, unlike solids, do not have a fixed shape, but they do maintain a constant volume. The particles are less tightly packed than in solids, allowing them to slide past each other, much like the fluid movements of dancers in a ballet performance. Lastly, picture that water evaporating into steam. Welcome to the gaseous state. Gases have neither a fixed shape nor volume. The particles are far apart and move freely in all directions, akin to birds flying unbounded in the sky. But why does the same H2O appear so different in these states? The answer lies in the amount of energy the particles have. In a solid, the particles have the least amount of energy, hence their confined movements. As we move to a liquid, the particles gain energy, allowing them to move more freely, and in a gas, the particles have the maximum energy, enabling them to move around without any restrictions. So, the next time you watch an ice cube melt into a glass of water or see steam rising from a hot cup of coffee, remember, you're witnessing the incredible dance of particles as they transition between the states of matter. Understanding the states of matter and their unique properties helps us in comprehending the world around us. Imagine a block of ice. It's hard, it holds its shape, it doesn't flow like water. Why is that? Well, let's dive right in. Solids, like our ice block, have certain unique properties that set them apart. They maintain a fixed shape and volume regardless of the container they're in. You can't pour a solid into a glass like you can with a liquid. Why is that, you ask? It all comes down to the way the particles in solids are arranged. In a solid, particles are snugly packed together in a tight, orderly pattern. It's like they're all at a party, but instead of mingling and moving around, they're stuck in their spots, only able to vibrate in place. This close-knit arrangement gives solids their rigidity, their fixed shape, and their resistance to change. Imagine a crowd of people tightly packed together in a concert. They can sway and jiggle to the music, but they can't really move around freely, just like the particles in a solid. This is why solids don't flow like liquids or gases. Their particles are just too close together and too orderly to move about freely. Now, because the particles in solids are so close together, they also can't be compressed much. Try squishing a block of wood or a piece of metal. It's not happening, right? That's because the particles are already so close together, there's just no room for them to get any closer. And it's not just about being packed tightly. The particles in a solid are also bonded together with strong forces. It's like they're all holding hands, refusing to let go. This strong bonding is another reason why solids maintain their shape and volume. So, in a nutshell, the properties of solids, their fixed shape, their fixed volume, and their inability to flow all come down to the way their particles are arranged and bonded together. So, solids are all about structure and stability, but what about liquids? Water flows, takes the shape of its container, but why is it so different from ice? Let's delve into the realm of liquids, one of the intriguing states of matter. Liquids, much like our beloved water, have the unique ability to flow. This is because, unlike solids, they do not have a fixed shape. However, they do maintain a fixed volume. You could pour a glass of water into a teapot, a vase, or a swimming pool, and it would effortlessly assume the shape of its new home, but the quantity, the volume of the water remains the same. But why is this? Well, it all comes down to the arrangement of particles. In solids, the particles are tightly packed in a rigid structure. They're like dancers at a ball, positioned in a precise formation, moving only slightly from their designated spots. In contrast, particles in a liquid are like attendees at a music festival. They have more freedom to move around, but they still remain relatively close together. This is due to the intermolecular forces of attraction that, although weaker than in solids, are still strong enough to keep the particles in close proximity. It's these forces that allow liquids to flow and take the shape of their containers while maintaining a fixed volume. You see, the particles in a liquid are constantly moving, sliding past each other, allowing the liquid to flow. This movement is also the reason why liquids can't maintain a fixed shape. The particles are always on the move, reshaping the liquid as they go. But it's not all chaos. There is a semblance of order in this fluid realm. The intermolecular forces ensure that the particles don't stray too far from one another. So, while liquids may seem free and unstructured compared to solids, they still have their own unique form of order. Liquids, while less structured than solids, still have some order. But what happens when we go one step further to gases? Or we can't see air, but we know it's there. What makes gases so elusive? Let's embark on a journey into the ethereal realm of gases. These elusive states of matter are fascinating because, unlike their solid and liquid counterparts, gases have no fixed shape or volume. They have this uncanny ability to fill any container, be it a small perfume bottle or a gigantic hot air balloon. This is because gases are not limited by intermolecular forces as solids and liquids are. Instead, they're free to move around, spreading out evenly throughout the available space. Now, think about the arrangement of particles in a gas. Picture a room full of hyperactive toddlers. They're running around, bouncing off the walls and each other, right? That's very much like the particles in a gas. They're in constant, random motion, colliding with each other and the walls of their container. And because of this constant motion, gas particles tend to occupy a greater volume than the same amount of solid or liquid substance. This freedom of movement is a result of the significant distances between gas particles. Unlike in solids where particles are tightly packed, or liquids where they're somewhat close together, in gases, particles are far apart. This spacing gives gases their compressibility. You can squeeze a gas into a smaller volume, but you can't do that with a solid or a liquid. Temperature also plays a critical role in the behavior of gases. When you heat a gas, the particles move faster and spread out, taking up more space. Conversely, when you cool a gas, the particles slow down and come closer together. This relationship between temperature, volume, and pressure is what makes hot air balloons rise and fall. So what's the takeaway? Gases are like the free spirits of the matter world. They're not confined by shape or volume. They dance around in constant chaotic motion, and the distance between their particles gives them their unique properties like compressibility and expansion. Gases, unlike solids and liquids, have their particles spread out, giving them their unique properties. So, we've taken a journey through solids, liquids, and gases, but what does it all mean? Well, let's take a moment to refresh our memories. We began our adventure with solids, those sturdy, dependable materials that hold their shape and volume. We learned that the particles in a solid are tightly packed together, almost like a team in a huddle, vibrating but not moving from their positions. This particle arrangement is what gives solids their fixed shape and volume. Then we moved on to liquids, the go-between state. Remember, a liquid takes the shape of its container but maintains a consistent volume. The particles in a liquid are less tightly packed than in a solid, allowing them to slide past each other, giving liquids their ability to flow. And finally, we soared with gases. The freest of all states, gases have no fixed shape or volume. Their particles are spread out and move in all directions, filling whatever space is available. This is why a puff of perfume can quickly fill a room. Understanding these three states isn't just a neat party trick. It's the key to understanding the world around us. It helps us make sense of why some things are hard and others soft, why some things flow while others don't, and why some things seem to disappear into thin air. From the ice in your drink to the steam rising from a hot cup of coffee, from the solid ground beneath our feet to the gases that fill our atmosphere, the states of matter are everywhere. They're an integral part of our daily lives, and understanding them allows us to better understand and interact with the world around us. The next time you see ice melting into water or water boiling into steam, you'll know exactly what's happening on a microscopic level. It's all just a matter of states.